We're going to look at calculating confidence intervals using the normal curve as our basis. There's a basic formula that sits under this which says that our population mean is equal to our sample mean, our best prediction, plus or minus this pile of garbage. And that pile of garbage is what we're going to look into next. Imagine for a second that we have a normal curve and we want to know at what z-scores, right here and right here, you would have the edge of the confidence interval of 95% being in the middle. Well, if 95% is in the middle, that means on each side we have 2.5% because there's 5% left over, and that's split equally between the two sides because the normal curve is symmetrical. And if you want to know what z-score corresponds to 2.5% at the very bottom, that's something that you can actually type right into your calculator. If you do the function inverse normal, so you go to your distributions on your TI-83, and you go to the function inverse normal, third one down on your distributions, you could type in 0.025, and that would tell you the z-score that would be right here on this borderline. And if you go ahead and do that, you're going to get negative 1.96. So negative 1.96. Now on this side, you could also say, well, if this is the top 2.5%, then I know that I have 2.5 plus 95, or 97.5% of the curve underneath here. So I could type into my calculator inverse norm 0.975. And what that's going to come out is to positive 1.96. And here's the trick. Once you find the lower end, you know that it's going to be the exact same as the higher end, just positive. So once you know one end, you actually know both ends. That value that we just calculated, the 1.96, is going to be the z-star in the formula from the screen before. And the reason we call it z-star is because it is a z-score, and it is a special z-score, a critical value that corresponds to 95% confidence intervals. Imagine you're faced with this problem. I took a sample of 300 students and asked them how many pairs of shoes they owned. The sample average was 5.8, so my x-bar is 5.8. Pairs of shoes is known to have a standard deviation of 2.7. Find a 95% confidence interval of this estimate. So 5.8 is my estimate, my x-bar, but I want to do a confidence interval around that. Now, when we did things with StatQ, we always needed all the raw data so that it could generate its own graph and give us a middle 95%. But now, when we use the normal curve as our basis, we actually don't need that information anymore. We can get by with what we have. So the mean and standard deviation will be enough, and it says known to have a standard deviation of 2.7. That's referring to a population standard deviation, and we'll talk about the difference between that and a sample standard deviation in a moment. But for now, the formula that you always use to create a confidence interval is going to be that your mean is equal to your sample mean plus or minus some amount. And that some amount is your critical value based on how confident you want to be. So a number that's based on 95% confidence, and that's your z-star, and that is multiplied by your standard deviation divided by the square root of n. And the reason that you take that your standard deviation divided by the square root of n is the central limit theorem. So if we were to jump straight into actually using this formula here, we're going to say that mu is equal to 5.8 plus or minus the z-star we calculated just a moment ago. That's for 95%. That's going to come out to be 1.96. And we multiply that by our standard deviation of 2.7 over the square root of our sample size, 300. And that would be our formula. So the only math that we actually need to do to calculate is multiplying and dividing over here. So I'm going to go ahead and do that. You can do that on your own. I'm going to just write the answer. And that comes out to 0.305, and there's some other decimals. If I were to round it off, I could round it off to 0.3 since this only goes to one decimal, or I could round it off to 0.31, and either would be fine with me. So if we were to say mu equals 5.8 plus or minus 0.3, that's going to be how you could express your confidence interval, and it's going to most naturally be in that plus minus form. You have the option to go ahead and do the plus and the minus. You would say that mu would be between 5.5 and 6.1, but generally just leaving it in this form right here is going to work just fine.